In comic books, it's seen that ordinary people getting mutations to their DNA develop superpowers of an extraordinary kind. However, mutations happen on a day-to-day basis in our normal lives, yet none of us are superheroes. We're going to see exactly how a mutation is today, as well as what the most common outcome of mutations are. Remember, DNA contains all the information about a cell. For example, the original one was AAAGGG, the mutated would be AAAGGT. For example, the original strand of AAAGGG, the mutated strand, would be AAAGGC. A mutation in the DNA is whenever a single change has been made at any point of the DNA, thus creating new DNA and thus a mutation. What causes a mutation? Anytime a base is knocked out of DNA, it has to be replaced. Sometimes mistakes are made or pulling in a new base. Mutations can commonly happen when some part of the DNA is removed, and then the base has to be replaced. Because there's been a change in the DNA, we call it a mutation. Radiation can cause a base to fall off. For example, sunlight. The sun spits out massive amounts of radiation. When this radiation strikes your DNA, it'll cause a base to fall off or become damaged. Thus, since there is a change, it's created a mutation. That's why a lot of times people get skin cancer from being out in the sun too long, the result of a mutation. When DNA is replicated, sometimes mistakes can occur. DNA replication is when one strand of DNA is then turned into two. This goes so fast, however, mistakes can be made, thus leading to a mutation. Sometimes this can result in cell death. What is the most common outcome of mutations? Nothing. Sorry folks, but most of the time when you get hit with a mutation, nothing happens. Instead, you remain exactly the same. So no X-Men. Here's why it happens. If you look at the codon table, you see that most amino acids are coded for by multiple codons. For example, let's look at the codon table here. Let's look at the box here. We see that the amino acid proline is coded for by multiple codons. That ensures that if there was a mistake at one point, you'll still get the proline in the end. Another example is leucine. Notice how it jumps around the table. Once again, while the codon may slightly change, it still may give you a leucine. This makes sure that while you may have changed DNA, the amino acid will be the same.